Okay, chapter 6, lesson 4, last lesson in the chapter on transformations. This lesson is about dilations. So think about dilations as making something bigger or enlarging things. I don't know if maybe you've ever had an eye exam where the optometrist or ophthalmologist has had to dilate your eyes so that way they can get a better look inside of there. So they put little drops in your eyes, make your pupil really big. Probably have to wear sunglasses home, that kind of thing. So when you talk about dilations, it's making something bigger, but it's the exact same something. So if this is our original right here in blue, they dilated every point, every ordered pair, the coordinate of every ordered pair, to enlarge it and make it bigger. Notice it's the exact same shape, only bigger. So it should make sense to you that if we talk about scale factors, which is basically what you multiply each coordinate by to get the new coordinate, if that scale factor, which they are using k, I'm not sure why they use k, but that's what they do. If that number is bigger than 1, so think about in general, if you multiply by a number bigger than 1 to anything, it's going to get bigger. Well, unless it's 0. So let's say 2 multiplied by 1, okay, it stayed the same. But if we do something bigger than 1, 2 by 2, 2 by 1.5, 2 by 1.5 would give you 3. All right, so anything bigger than 1, your shape is going to be bigger. If it's in between 0 and 1, so in other words, if it is a fraction, like 1/2, then your new image would be, each coordinate would be half of what it was now. That is not to say that the area is going to be half. The area and perimeter and all that, that works completely separately, which we can talk about that at a later time. But it's just saying that the coordinates of every ordered pair, the numbers would be half. So again, if the scale factor is k, look at how they write this. This is the dilation notation that they are talking about. So it's saying that each ordered pair, to get the new ordered pair, you're going to take, and two letters right next to each other, it means multiply. You're going to multiply the x by whatever the scale factor of k is. You're going to multiply y by whatever the scale factor of k is. All right, so let's try one of these. Okay. Example 1. A triangle has vertices A, B, C. Find the coordinates of the triangle after a dilation with a scale factor of 4. So if the scale factor is 4, what is that saying? It's saying that you're going to take each one of these and you're going to multiply each one of these numbers by 4. All right, so 0 times 4, 0 times 4. Both of them are still 0. B, 4 times 8, 32. So B prime, 32, 0. C prime, 3 times 4, 12. Negative 2 times 4, negative 8. So this is A prime, B prime, C prime. A prime, B prime, C prime. And that's all they ask you to do. They just say, what are the new coordinates? If the scale factor is 4, it just means you're going to multiply each of those by 4. Easy enough, right? So let's pause it, and I want you to try got it right there at the bottom. Okay, scale factor is 2. Then I'm going to take each one of these and multiply it by 2. So what would I get? I would get a W prime of negative 4, 8. I would get an X prime of 2, 8. I'm just multiplying each one of these by my scale factor of 2. Y prime, I would get negative 6, negative 2. And the last one, Z, it's supposed to be a Z, prime, would be 6, negative 2. Not 16, that's my parenthesis. 6, negative 2, because again, I'm just multiplying everything by 2. So, easy enough. So that's if the scale factor is above 1, right? Each one of them should get bigger. In the next example, the scale factor is 1/2. So basically, each of the numbers in the original image, it's going to be 1/2 of that amount. So in this one, it says, here's J, K, and L. Graph the original figure, which that's what they've got right here in the blue. J, K, and L. And the image of the figure after a dilation with a scale factor of 1/2. So you're going to take each one of these and you're going to multiply it by half. The same thing as multiplying it by half is the same as dividing by 2. So you're talking about 1/2 of, remember of means times. So you're talking about 1/2 of 3, 1/2 of 3, 1.5, or they actually leave it as 3 over 2, which is fine, it's the same thing. 1/2 of 8, 1/2 of 10, 1/2 of 6, 1/2 of 8, 1/2 of 2. So then they come up here and they graphed 1.5 and 4, 5, 3, and 4, 1. All right, so you've got the blue image right there. Now, those red lines, here's a way to check, and you don't have to do this, but I highly recommend that you do. Whenever you start talking about dilations and things are bigger and you don't want one leg to be bigger than the other, right, kind of make it hard to walk. If you do the origin, you should be able to draw a line from the origin and pass through both the original and the new point. From the origin, pass through the original and the new point. If you can do that to all of them, then you dilated it correctly. If you can't, if somehow one of them is astray somehow, then that point is probably wrong, and so you can go back and double check that. So again, I would highly recommend that you do that. All right, pause it and try B down here for got it, and then we'll work through this one together to make sure that you do. Okay, so figure has vertices F, which is -1, 1, right here, that's F. G is 1, 1. H, 2, -1, that's H. And I is -1, -1. What shape is this? Don't be sitting there saying, oh no. It's a trapezoid. Trapezoid. 2 parallel sides, the other 2 are not. All right, so that trapezoid. It says graph the figure and the image of the figure after a dilation with a scale factor of 3. So if this number right here is bigger than 1, that means our end result should be bigger than our original. All right, so I'm going to take everything here and multiply it by 3. So F prime, -3, 3. G prime, 3, 3. I'm just multiplying each one of these by my scale factor, which is 3. So H prime, 6, -3. And I prime, -3, -3. All right, so my dilated image, F prime would be -3, 1, 2, 3, 1, 2, 3. F prime. G, 3, 3. H prime, 6, -3. 1, 2, 3, 4, 5, 6. 1, 2, 3. Now again, this looks a little off, a little crazy that H would be all the way over here, but that's why we're going to check it here in just a minute. -3, -3. That's I prime. So here's my new trapezoid. Okay, so again, if I check this, should be that I can draw a line from the origin and be able to go straight through each of those points. It's kind of squeaky. So if I can do that, then that means that I did dilate it correctly, more than likely. All right, so that looks good. All right, let's go ahead and look through example 3 here that's coming up next. Through a microscope, the image of a grain of sand with a 0.25, so 1/4 of a millimeter diameter, appears to have a diameter of 11.25 meters. So it's enlarged it. After all, that's what microscopes do anyway. So what is the scale factor of the dilation? So I'm sure you remember from science class, whenever you can turn it and look at different magnifications. All right, so it's asking you what magnification is this? So it's asking you how many times bigger did the microscope make it? So if it was 0.25 and now it appears to be 11.25, how many is that? So how many of these can you fit in these? Let's do normal numbers, ones that you may be comfortable with. What would you have to multiply 2 by to get to a 6? How many times can this fit in here? Well, then that's just a division problem. Of course, you know it's a 3. 2 times 3 is 6 because there's 3 sets of 2 in 6. So how many sets of 0.25 can I get in there? Well, I'm just going to have to get out my calculator. 11.25. And, whoa, that's not my number. 11.25 divided by, I want to know how many sets of 0.25. 45. So that would be like a 45 magnification lens. 45 times bigger. That's what we're talking about. All right. So I'm going to leave, well, thought I would leave it up there. Maybe not. You will need it to try got it on the top of the next page. So hopefully with your calculator, you can use the one on the iPad. Do this problem to find out. Pause it and try it, please. All right. Lucas wants to enlarge a 3 by 5 inch photo to a 7.5 by 12.5 inch photo. Odd request, but again, Lucas may be a little odd himself. Who knows? What is the scale factor of the dilation? So what they are saying is, how many 3's can fit into 7.5? How many 3's can fit into 7.5? So if we get our calculator back here, how many 3's can fit into 7.5 means 7.5 divided by 3. Do not do that the other way. Do not do that the other way. If I say how many 3's are in 7.5, it does not mean 3 divided by 7.5. Just like I showed you this example right here just a minute ago. Let me concentrate here. If I know that this is a 3, right? 2 times 3 is 6. Does that mean that there are 3 6's in 2, or does that mean that there are 3 2's in 6? Of course it's 3 2's in 6. So if I want to know how many 3's are in 7.5, it means I'm going to take my bigger number and divide it. This we divided, and that's how I got a 3. So in order to get how many 3's are in 7.5, it's going to be 7.5 divided by 3. 2.5. Now, I wouldn't just leave it as that, because again, something crazy may have happened with your calculator. You may have pressed the wrong number. You also know that a scale factor kind of keeps things in proportion. It also wants 7.5. So if it's 3 by 5, that's 7.5 to 12.5. So that means 3 goes into 7.5, 5 goes into 12.5. So 12.5 divided by 5. You also get 2.5. So that means the scale factor is in fact 2.5. So you could either write 2.5 or you could write 2.5. Either way. Okay, with that being said, hopefully it's all clear to you on how we do dilations. Remember, it's just that you take each coordinate of each ordered pair by the scale factor. And again, they use k as the scale factor. Sometimes it's bigger than 1, so I would think that all of these are going to end up being bigger. How much bigger? Twice as big. This one is less than 1, so that means all of these are going to be actually a fourth of what they are now. Sometimes it comes out even, sometimes it doesn't. Just depends on how lucky you get. So, should be good enough. Should have no issues with that, but again, as always, come see me if you do. Good luck.